Welcome to the third video in the series Law of Sines. So let's say we've been given the description of an angle and the side opposite that angle, as well as another side, or ASS. What do we need to look for? First, let's make the chart so we don't overlook anything. We have side A and angle A opposite from each other, so let's start with that ratio. We are looking for angle B, so that's what will go on the bottom, the sine of B, and on top we have the length of side B. Here is the result of our cross multiplication. We divide both sides by 9.8, and then we take the inverse sine of both sides, and we get undefined. Yes, we get undefined because this 9.8 is actually too short to ever touch side C. So there is no solution. Now, if you do get undefined on your calculator, first make sure that you entered everything correctly. And if you still have undefined, then there is no way to solve that triangle. Let's look at another case. So let's take a look at this triangle with side A is 850, side B is 793, and angle A, which is opposite side A, is 38.7 degrees. Now, don't get too hung up with the positions of the A's, B's, and C's. You can rotate this triangle around to get it to fit into this format if you want it. Move whichever angle and opposite side you have until they are in the position that we have usually seen them, with the A to the left and the B to the right on the bottom of the triangle. So here it is, holding still. Let's go ahead and solve the triangle. Find everything that's missing. All right, once again, we have side A of 850 divided by the sine of angle A, which is 38.7 degrees. And we're going to look for angle B, because we already have side B. We have part of that ratio. We have to find the other part, the angle. Cross multiply, divide both sides by 850 to begin to isolate our angle B, and find the inverse sine of both sides. Turning to our calculators, we find B equals 35.7 degrees. That's the first of the three missing parts of the triangle. Now we need to either find side C or angle C. And since we have two angles of the triangle, we can just subtract those two angles from 180 degrees, which is an exact number, and we get 105.6 degrees. There's the second of our three missing pieces. Now finally we have to go back to our ratios to find side C. Once again, we return to our original angle opposite side pair of the A's, 850 over the sine of 38.7. We'll set that equal to side C over the sine of angle C and cross multiply. So there's the cross multiplication. And now, as you can see, we still have some more steps before we can find C. We have to isolate C by dividing both sides by the sine of 38.7. Then we turn to the calculator. So side C equals 1,309 point blah, 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 blah. We need three significant digits. 1, 3, 1, 0. There we go. 1310 is the side C. We have found all three missing parts of this triangle. We have solved the triangle. Do you recognize this triangle? It should look a little familiar. But let's look at it a little bit more. If you were to swing side A to the left to see if you could make a smaller triangle, because that side is longer than side B, you're not going to be able to form a triangle that has this angle of 38.7 inside it. Just pause and think about that for a moment. Pause the video. So for this triangle, there is only one solution. And there you have it, all 6 parts of it. One solution for that triangle. And moving on to one more example. All right, let's have a go at this one. Triangle ABC with side B equals 32.5 and side A equals 27.6 and angle A equals 47.2 degrees. Let's put that in a chart. Now we set up 27.6 divided by the sine of 47.2 equals, we are now trying to find angle B, so we will put the sine of B on the bottom and side B, 32.5, on the top, and cross multiply. To begin isolating angle B, we're going to divide both sides by 27.6 and take the inverse sine, plug it into your calculator, get the answer. So since there are 180 degrees in a triangle, and we have already used up some of those degrees for A and B, the only degrees in that triangle left for C are 73.0 degrees. Now we can find the last part of our triangle, side C. Set up your same initial ratio, side A over the sine of angle A. And then we now have 73 degrees for the measure of angle C, and we're looking for side C. Cross multiply and divide both sides by sine of 47.2 and apply your calculator to get 36.0. However, let me get this out of the way, because we can swing that right-hand side, side A, and if we swing that, it's going to come in here and hit side C again. Let's draw a picture of that. If we swing that side, then look at this, we're cutting into that 73 degree angle. It will no longer be 73 degrees up there. So we will indicate the change of measurement with the prime up here. Also, B is no longer over here at this corner. The third or second, however you count it, vertex of the triangle will be here, and we'll call it and its measure B prime. But how do we determine the measure of B prime? Let's take a closer look at the triangle again. Now it begins to look like something we've seen before, especially if we remember that this side, because we swung it over, is the same measure as the other. We have an isosceles triangle, and the base angles of an isosceles triangle are congruent. Therefore, this angle is 59.8 degrees. However, that's not in the triangle now, because the triangle we are interested in is this one, A, B prime, C prime. This is the trickiest part of working with this type of triangle. If you find you need a little bit of review of geometry to totally grasp these concepts, you can go back to the beginning of your book. There is geometry review there. All right, so what we have with this little extension of the bottom there is two supplementary angles. One of them 59.8 degrees and the other 120.2, because if you add them together you get 180 degrees. So let me replace what I brought down and bring down the triangle in which we are actually interested. Here it is cleaned up and enlarged a little bit so we can see better the components. And let's clean up this other part of the page so we have some room to do some calculations. Page, screen, whatever. All right, now that I've reorganized the screen, we have room to put in the chart for the new triangle. Notice that side A is still equal to 27.6, side B is still equal to 32.5, and angle A is still equal to 47.2 degrees. That's because that's what we were given. With that information, you can draw either of those two triangles. We have to solve both of them. B prime has changed, or B has changed to B prime. C has changed, and also the length of C down here has changed, so that has to be expressed as a small c prime. Thankfully, we don't have to do quite as much work now, because if you look at the last diagram I drew, we know it's equal to 120.2 degrees, B prime. All right, that means C prime is 180 minus 47.2 minus 120.2, so 12.6 degrees. And let's go ahead and box the two formerly missing parts that we have now found. Now we only have to find C prime. Set up your proportion as usual with side A over the sine of angle A, the things that you knew from the beginning. We are still looking for C prime. It goes in the numerator, and underneath that goes the sine of angle C prime, or the sine of 12.6. Cross multiply, solve for C prime, and you should get 8.21. And we are done. We have solved both triangles that can result if you know an angle, its opposite side, and another side, or angle, side, side. In the content area of Blackboard, you will find a PDF that explains this process and goes further and explains the law of cosines. So please take a look at that. Read the appropriate pages in your textbook, and we will talk about all of this next time we meet in Blackboard Collaborate. We should have a lot to talk about.